There are three properties of gas: volume, pressure, and temperature. When we are given a scenario where one of those properties stay consistent, we can use different laws and formulas to help evaluate said scenario. When the temperature of a gas stays consistent, then we use Boyle's law. When the pressure of a gas stays constant, then we use Charles' law. And lastly, if the volume of a gas stays consistent, then we use Gay-Lussac's law. An example of Boyle's law is spray paint can. Spray paint has the relatively constant temperature and uses a decrease in volume to increase pressure spraying the paint. An example of Charles' law is a hot air balloon. The pressure of a balloon stays the same, but the bigger the size of the air balloon or volume is, the more temperature is needed to make it float. An example of Gay-Lussac's law is heating an aerosol can. The volume of the can stays the same, but if the can gets too hot, the pressure will increase too much and it will explode the can.
Aerosol cans turned into missiles.
I wonder what would happen if someone cooked soup at low altitude and another person cooked soup at high altitude. How would they solve that dilemma?
Okay. Oh wow, I love cooking soup, but I don't know why mine is cooking slower than theirs.
It's because of Gay-Lussac's law, silly.
How does a gas law apply to cooking soup?
We already know Lussac's law is the law of constant volume. Since both of us are cooking the same soup cans, meaning same volume, the pressure and temperature are directly related. Both factors will increase or decrease with each other. Since you're at a higher altitude, the pressure is much lower. This also lowers the temperature and therefore boiling point of water. The water boils at a lower temperature and cooks the soup slower because it is not as warm.
Wow, you're so smart, Darren. I'm so happy that you taught me that when pressure and temperature are related, and pressure is lower at a higher altitude, the boiling point of water is lower. In that case, things will cook slower.
No problem.
Now that we solved this dilemma, we can eat our soup together. We can eat our soup all in the name of chemistry.
Cheers!